Hello everyone, in this video I'm going to be going over three-phase power generation as well as the construction of a three-phase generator. First off, how is energy generated? This involves turning kinetic energy into electrical energy. This is done by exciting electrons magnetically with an inductance coil. Three-phase generators have three of these coils, hence three phases. Now, I don't own any of these pictures, just a disclaimer, but as you can see in the diagram, we have the prime mover in generator and then power out is in three-phase output. The prime mover is whatever is supplying the kinetic energy, so this can be a wind turbine, a hydroelectric dam, anything you can think of in power generation. Let's go through the construction of the three-phase generator. So as you can see in this nice little cutout diagram, it gives a good view of the generator's makeup, but I'll be going into more detail in the next slides of each component and their purpose. The stator. This is the part of the generator that remains stationary. The stator frame is basically the outer shell of the generator that has fins that assist with cooling as they allow for more surface area for heat to diffuse. The stator core is made out of laminated metal sheets that provide a low reluctance path for the flux generated by the stator windings which are housed on the stator core. The stator windings are constructed of enameled copper wire, the wire being enameled to ensure that the wire does not act as a clump of metal that would have more resistance. These windings get current induced by the rotation of the magnet within the generator. These windings serve as the output of electrical energy within the generator. The rotor. This is the part of the generator that rotates, rotated by the kinetic energy input, so the prime mover we just mentioned. The rotor core is made out of laminated metal sheets like the stator core and acts as the core of an electromagnet, the rotor basically being an electromagnet. The rotor core being made out of laminated metal strengthens the magnetic field produced and also provides housing for the rotor windings. The rotor windings are enameled copper wires like the stator windings and act as the coil of an electromagnet, enameled to ensure that they act as a long length of wire rather than a high resistance clump of metal. When they have direct current pass through them, the rotor turns into a magnet when the rotor spins, resulting in the needed EMF. The slip rings are copper wires that connect the rotor to the stationary external circuit, maintaining electrical contact within the rotor windings as they rotate, ensuring continuous and steady rotation. The brushes. Like slip rings, brushes are used in order to maintain electrical contact with the rotor. These carbon brushes press against the slip rings, which ensures a stable connection with the rotor and the external circuit, as the brushes are part of the external circuit. The bearings. These metal components provide support to the rotor while also allowing the rotor to rotate, as the bearings can turn, while means that they are connected to the rotor. The rotor can now smoothly turn with them. Shaft. This metal component is what transfers the kinetic energy to the generator by being turned when the connected fins are moved by the prime mover. Now that I've fully explained the generator's construction, let's go into more detail about three-phase power. So first, here's this little diagram that explains three-phase power. So you have phase 1, phase 2, and phase 3. They're pretty much the same signal, only they're offset from each other. So we choose three-phase power because if we just use normal power, then basically, and by normal power I mean single phase or two-phase, the more phases the better, because if we only have one or two phases, then basically our lights would be going on and off randomly but for every time that the wave dips. So because we have three different phases, the wave never drastically dips, and we do, however, have really tiny dips, as you can see. So if you actually have a slow motion camera and view one of your lights in slow motion, you can actually see it very quickly, dimming and then going brighter again, a very small amount, and that's the little phase shift. So basically, this little three-phase system provides a very stable and reliable signal. Thank you for watching. I hope this video was helpful, and please like and subscribe. In a later video, I'll be going over how the transmission is done, probably.